Good morning, my dear students. I am Mohammad Bahaddin, working as an assistant professor in ISN Enjoying College, which is affiliated to the Usmania University in Hyderabad. So, today in these sessions, we are going to learn problems on how to design a pair of helical gear. Design a pair of helical gear to be transmit the power. Power is given here 15 kilowatt at a speed of 10,000 rpm of the pinion with the pitch circle diameter is given as 80 mm. The transmission ratio is given as 3:1. The pinion and gear are made of the same material. This pinion as well as the gear, it is made of the same materials. Is it right? So first of all, we have to write down the given data in which we have to represent the power transmitted by the gear. How much pair of helical gear are to be transmit the power? The power is given as 15 kilowatt. 15 kilo nothing but 1000 watt. The speed of rotations of the pinion N1 is given as 10,000 rpm. So if you want to convert in the minute to second, just you need to divide by 60. 10,000 by 60, then you will get the 166.6 rps of the pinion. Okay, and here transmission ratio I value is given as 3:1 is given over here. Clear? So after that, D1 nothing but diameter of the pinion is given here 80 mm. So in the such type of the problem in which we need to assume the pressure angle alpha should be 20 degree full depth invalued. Okay, as well as here in the helix problem, the angle of beta should be 45 degree because we have cut the angle in such a way that they're making the angle of 45 degree. So pitch line velocity formula we have V is equal to pi d1 n1 by 1000 pi into d1 is how much is the diameter of the pinion is given as here 80, and the speed of rotations of the pinion n1 is given as 166.6 by 1000. If you divide the value, then you will get the answer is 41.89 meter per second. After getting the value of pitch line velocity, we need to know about what is the static strength of the pinion and what is the static strength of the gear. We need to find out because the pinion and gear, it is made of the same material. For that reason, you need to select or choose the cast steel is 0.2% C heat treated with the static strength of the pinion equal to the static strength of the gear equal to 193.2 megapascal. Clear? And the Brenner hardness should be 250. So we have to refer for both pinion and as well as for the gear. So you have to refer the table number 12.7 and page number 234. After getting the value of sigma d1 and sigma d2, our intention is there we want to find out the value of torque. If you want to find out the value of torque, we have to use the formula is P equal to 2 pi n1 into T by 60 into 1000 into CS. So always I told you for the CS equal to always we need to consider for the 1 for the study load. Okay, so this one from 8 to 10 hour per day, the person is per day it is doing the work. So for that reason you have to refer the CS value should be always equal to the 1. So you have to refer the page number 12.31, page number 247. After that, the power transmitted by the pinion should be given as 15 into 10 power 3 equal to 2 into pi into n1 nothing but the speed of the gear or speed of the pinion is given as 10,000 into the torque by 60 into 1000 into CS values should be equal to 1. After that, if you cross multiply value, this should be 15 into 10 power 3 into 60 into 10 into 1000 equal to 2 pi into 10,000 into torque. If you divide this value, then you will get the moment of torque value T is equal to how much? 14323.944 Newton mm. After getting the value of moment of torque, we need to find out the velocity factor value. So always you need to remember that velocity, if it is greater than 20 meter per second, then you have to refer this formula CV is equal to 5.55 by 5.55 plus under root of V. So after that, CV is equal to 5.55 as it is by 5.55 plus under root of velocity V, how much we got it here. So V, how much we got it here, 41.89 meter per second. Okay dear, so already we understood that 41.89 meter per second, so velocity is greater, so for that reason we are using this formula. If velocity is lesser than 20 meters per second, we have to use another formula. Is it right? Then so if it is velocity is greater than 20 meter per second, because velocity how much we got here, 41.89 we got it, for that reason we are using this velocity factor value formula. CV is equal to 5.55 by under root 55 by 5.55 plus under root of V. So you had to refer the page number 214 and equation number 12.25D. So from you can easily find out if you substitute the value of V is 41.89. If you divide this whole the value with the help of calci, then you will get the value of velocity factor is 0.46. So after getting the value of velocity factor, we need to find out the beam strength of the tooth. We need to find out. So already we know very well, we have the formula for the beam strength of the tooth is Mn is equal to 2 into moment of torque into the wear and lubricant factor CW, wear factor into cos beta by the static strength of the gear or pinion into CV. We know very well the velocity factor, and K nothing but the load factor, Y nothing but the form factor, and Z nothing but the number of teeth on the gear. Then after that, the key formula is different in the helical gear. We have to use the key K is equal to B by Mn. So you have to refer the page number 214 and equation is 12.24b. Okay, after that the B value should be different over here. B we have to use according to AGMA, the face width value B equal to how much is there, 1.15 pi into Mn by sin beta. So you have to refer from the page number 12.23 and so equation is 12.23, page number is 213. Okay here, after that let us see K as it is. So B value how much is there, 1.15 pi into Mn by sin beta by Mn. So after that this Mn and this Mn will be cancelled over here. Then if you divide over here this, then you will get the value is how much is there, 5.1093. that is the value of K. After getting the value of K, then we have to go for equivalent teeth on a pinion. We need to find out. If you want to find out the equivalent teeth on the pinion, we need to design based on the pinion. For that reason, Z is equal to Z1 by cos cube beta. Z1 as it is, cos cube as it is, beta nothing but 45. If you divide the value, then you will get the answer is 1 by cos cube 45. Then you will get the answer is 2.8 Z1. After that form factor, we have the formula, because our intention is there this equivalent teeth on a pinion we need to substitute in the form factor. Is it right? What is the formula is there? Y equal to pi into Y. So pi as it is, Y1 nothing but with the help of Levis equation of a form factor, we have the formula is 0.15 minus 0.912 by ZE1. So you have to refer from the page number 204 and equation is 12.5D. 0.154 as it is, 0.912 by ZE1, how much is that, 2.8 into Z1. So if you cross multiply over here, 0.154 into 2.8 Z1 minus 0.912 by 2.8 Z1. So after getting the value of Y1, you need to substitute it in the above equations over here. In this equation number 12.24b, in which we need to substitute the value. Mn as it is, just need to cross multiply over here Y1 into Z1. The remaining should be how much is that, 2 into 1433.944 into CW value is 1.15 into cos beta value is 45 by sigma, the study strength of the pinion, it should be how much is there, 193.2 into CV value is 0.46. okay, and K value is 5.11. okay here. After that, So we have the formula for Mn is, what is the formula is there, d1 cos beta by z1. So d1 nothing but 80 into cos beta nothing but cos 45 by z1. So if you multiply 80 into cos 45, then you will get 56.57 by z1. Just need to substitute over here, okay, 56.57 by z1 whole cube into the y1 nothing but the form factor value. We know very well this value. Just need to substitute over here. Pi 0.154 into 2.8 z1 minus 0.912 by 2.8 z1 into z1. This z1 and this z1 will cancel. The remaining should be, if you divide the whole the value, then you will get the answer is 51.3. okay, and then here this z1 whole cube just need to cross multiply over here. It make as over here z1 whole cube, the 56.57 cube into pi, and then if you divide this value, then you will get the answer is 0.154 into 2.8 z1. okay, then minus 0.912. This 2.8 just need to cross multiply over here. 51.3 into 2.8 into z1 whole cube. Clear? Then after that, just you need to multiply over here 56.57 whole cube into 3.142 into 0.154 into 2.8. If you multiply this whole the value, then you will get this value 245,237.65 z1. Plus into minus should become as minus. Again you need to multiply 56.57 whole cube into 3.142 into 0.912. If you multiply, then you will get the answer is 518684.47. After that, you need to multiply 51.3 into 2.8, then you will get the value is 143.64 z1 cube. Clear dear? After that, let us see over here. If it is this value, it's moved toward this side, it become as minus 245237.657 z1. This minus it's become as plus toward this right hand side, plus 518684.47 equal to 0. So you need to calculate with the help of calci in the form of ax cube plus bx square plus cx plus d equal to 0. So if you calculate with the help of z1, the number of teeth of the pinion, z1 is how much is there, 40.21. It should be approximately equal to the number of teeth on the pinion should be how much is there, 41. After they getting the value of number of teeth on the pinion, we can easily find out the number of teeth of the gear. We can easily find out with the help of I formula. I is equal to the transmission ratio formula is z2 by z1. I how much is given, 3 is given. The number of teeth of the gear we need to find out. The number of the teeth of the pinion, how much we got here, 41. Just you need to multiply over here 3 into 41, it become as 123. So the number of teeth on the gear z2 is equal to how much we got it here, 123. We got it. After the getting the value of z2, we need to find out the value of a module. So mn is equal to 56.57 by z1. Clear? 56.57 by z1 is value is how much is there, 41. If you divide the whole the value, then you will get the answer is 1.379. It should be approximately equal to, we can say that it should be module 1.5 mm, we can say that. After that, we need to find out the most important thing is that the center distance between the two shafts. One is the gear shaft, another one is the pinion shaft. So we have the formula is equal to z1 plus z2 by 2 into mn by cos beta. So the number of the teeth of the pinion, how much we got, 41, we got it, is it right? Plus z2, the number of the teeth of the gear, how much we got it here, 123 by 2. And then modules is how much we got here, 1.5 by cos beta value is 45. If you divide the value with the help of calci, then you will get the answer is 174 mm. Always you have to remember, because I am refer the design to handbook by the Mahadevan. Always you have to go for Mahadevan. Okay, then the form factor for the pinion and gear, we have the formula for the pinion is y1 is equal to pi 0.154 minus 0.912 by ze1. So we have the formula for ze1 is equal to 2.8 into z1. 2.8 as it is z1, the number of the teeth of the pinion should be how much is there, 41. If you multiply the 2.8 into 41, then you will get the answer is 115. Then pi as it is 0.14 as it is minus 0.912 by 115. If you divide the whole the value, then you will get the form factor for the pinion is 0.4589. The pinion the form factor for the gear is y2 is equal to, we have the same formula. Instead of ze1 we have to use the ze2 only, that's it. And ze2 we have to use the same formula only. Instead of z1 we have to use here z2, 2.8 into z2, 2.8. The number of the teeth of the gear, how much we got here? 123. Just if you multiply 2.8 into 123, then you will get the answer is 344. Just substitute over here. After that, if you are calculated with the help of calci, then you will get the form factor for the gear is 0.4755. After that, you need to draw one table. Okay, so in the table you have to represent here one parameter in which pinion and gear. The number of teeth of the pinion is 41, we got it, and the number of teeth of the gear is how much is there? 123. And the allowable static stress sigma d1, how much is there? Here already we have found the 193 for the allowable static stress of the pinion, and the allowable static stress for the gear is 193.2 because of both are same. So for that reason, the allowable static stress for the pinion as well as for the gear should be remaining same. And the form factors is 0.4589 and the 4755 form factor for the gear. And the static, or we can say that the static strength factor, we can say that sigma d into y. Just you to multiply sigma d into y. 193.2 into 0.4589, then if you multiply, then you will get the static strength factor is 88.66 megapascal. If you multiply 193.2 into 0.4755, then you will get 91.87. So if you observe over here, who is having the strength factor is maximum, because the gear is having the static strength factor should be maximum. So for that reason we can say that so gear is a stronger one and the pinion should be the weaker one. So after that we need to design on the gear. So we can represent here the static strength of the gear should be greater than the static strength of the pinion. So for that reason we need to design on the pinion. So first of all we need to find out the phase width. We need to find out, if we want to find out the phase width, we have to use the formula is B equal to 1.15 pi into mn by sine beta. 1.15 as it is, pi as it is, mn nothing but 1.5, sine beta nothing but sine 45. If you divide the whole the value, then you will get the value of phase width is 7.7 mm. Okay, after that we need to find out the tangential force. We need to find out, we have to check the gear for the tangential tooth load. We need to find out. So for that reason you have to use the tangential force formula from the page number 214 and equation is 12.24. So the static strength for the pinion is 193.2 into CV is velocity factor value is 0.46 into, and phase width is 7.7, we got it, and the form factor is 0.4589 into module is how much we got? 1.5 by CW, how much we got here? 1.15. If you divide the whole the value, then you will get the tangential force is 409.61 Newton. After getting the tangential force is acting on the helical gear, after that we need to find out how much power transmitted to the tangential load. We need to find out. So after, you need to remember one thing, whatever the power is given, whatever our answer is getting, our answer should be greater than the whatever the power is given in the problem. Then only we can say that our design is safe. Otherwise our design is not safe. So power, we have to use the formula is tangential force into linear factor by 100 into CS value. CS you need to consider as the 1, and the tangential force, how much we got here? 409.61 into velocity factor value is how much is there? 41.89 by 1000 into CS value is how much is there? 1. If you divide the whole the value, then you will get the answer is 17.16 kilowatt. So we can say that this 17.6 kilowatt, it's a greater than the whatever the power is given in the problem. How much power is given? 15 kilowatt. For that reason we can say that the power transmitted to the tangential load is greater than the whatever the power is given in the problem. So hence the design is safe. Our answer is how much we got here? 17.16. So in the problem how much is given the power? 15. So we can say that our power transmitted to the tangential load is greater than the whatever the power is given in the problem. Okay, so for that reason, hence the design is safe. After that we need to find out the VL load. We need to find out, if you want to find out the VL load, you have to refer the equation from the 12.26C page number 214. So okay, After that, you have to refer from table number 12.16, page number 239 for the pinion hardness number. You have to consider as here 250, because the both and pinion is made of the same materials. So for that reason, we have to consider over 20 degree invalid full depth. We have to consider over here, and the stress factor we have to consider over here is 0.902 Newton per mm square. Clear? After that, our intention is there. First of all, we need to find out the value of Q. We have the formula Q is equal to 2Z2 by Z1 plus Z2. 2 as it is. Into Z2, how much is there? Z2 is 123. The number of the teeth on the pinion is how much is there? 41. The number of the teeth on the gear, how much is there? 123. If you divide the value of Q, then you will get the answer is 1.5. After getting the value of 1.5, you need to substitute in the above equation. FW equal to, okay, here D1 value is how much is there? 80, and Q value is and B value is how much is there? 7.7, and Q value is how much is there? Q value is 1.5, and we have the K value is how much is there? 0.902 by here cos square beta nothing but cos square 45. If you divide the whole the value, then you will get the answer is 1666 points Newton. Okay, so VL load, we can say that VL load should be greater than the dynamic factor load. For that reason, our condition is satisfied. After that, we need to find out the how much power developed due to the wear. We need to find out. If you want to find out P, we have to use the formula P kilowatt is equal to FW into V by 1000 into CS. So we have to substitute over here 1666.9 into V nothing but the linear velocity 41.89 by 1000 into CS value is 1. If you divide the value with the help of calculus, then you will get the answer is 69.82 kilowatt. So this means that our power is how much is given? 15 kilowatt is given. Whatever the power developed to the VR, how much we got in here? 69.82 kilowatt. So this means that our design is safe. So whatever our answer is there now, it should be always greater than the whatever the power is given. If it is lesser, then we can say that our design is unsafe. Clear? Check for the dynamic load, we need to check it. So we have to use the formula for the dynamic load. Refer the page number 214 and equation is 12.26. So in which the K3 value we are taking here 20.67 we are taking over here. The first of all, what I am doing here, we are finding the tangential force on a pinion we are finding. Clear? Tangential force, we have the formula is Ft is equal to 2mt by d. So here 2mt, moment of torque is how much we got it here? 14323.66 by 80. If you divide the whole the value, then you will get 358.1 Newton. So that is the value of tangential force. K3 value is how much is that? 20.67. After that is the most important dynamic factor value. Okay, then so the module we got it as a 1.5. The data is not available from the table based on the velocity how much we got it here? 41.89 meter per second. For that reasons, we have to select the error is how much is there? 0.127 mm. You have to refer from the table number 12.13, page number 237. Okay, then you have to write over here, because if you refer the table number 12.12 and page number 236 for 20 degree full depth invalid profile, then C value is how much is there? 114.4 Newton per mm, and C value is how much is there? 228.9 mm. For error is given as here 0.01 mm and E is given as 0.02 mm. So 0.01 mm is given here, error is given for the pinion is given as 0.01, and the C value is given here for the pinion is 114.4 Newton per mm. And then for the gear, the error value for the gear is given as 0.02 mm, and the C value is given here for the gear is 228.9 mm. So this is the value for the gear and this is the value for the pinion, and this X is the center distance value. So in which we are taking over here is the over error actions between these two gears. So 0.127 mm. Clear? Then how to substitute variable? First of all, take this upper value minus lower value 228.9 minus lower value is 114.4 by 0.02 minus 0.01 equal to this center value. How to take this x value 0.127, the center value 0.127 minus toward lower value Pinion 0.01. If you divide with the help of calci, then you will get the answer is x is 30.915 Newton mm. After that, we need to find out the value of C. Just you substitute over here. C is equal to how much is there for the Pinion is C is equal to 114.4 plus x 114.4 plus x value is how much is there 30.915. If you add this value, then you will get the 145.315 because we are designing on the Pinion only, because here Pinion is weaker section over here. After that, we need to find out the dynamic force. We need to find out. So we need to substitute in the above equation over here. This above equation, if you substitute the dynamic load in the above equation, Ft plus K3 into V C into B cos square beta plus Ft into cos beta by K3 into V plus under root of Cb into cos square beta plus Ft. If you substitute over here, then you will get the answer is dynamic force is 985.18 Newton. I hope so no one is having the doubt regarding up to this problem. If you have the doubt regarding this problem, please write down in the comment box and don't forget to subscribe my channel here. Thank you.